Hello, everyone. I always like to start with doing a little test of your classical education. So how many people know where this quote comes from? It's always equally depressing, actually, to do this test. So this is from Shakespeare's The Tempest. But the picture is actually from the National Archives in Washington, D.C. And I think it's a bit appropriate because this is what we try to do in our company. It's to know about as much as possible about the present and the past to be able to say something about the future. So I'll be talking about creating threat analyst centaurs. Just very briefly, so I come from Recorded Future. We're a company, we do threat intelligence. I'll describe a bit more what we mean by that. We've been doing this for 10 years now, so we started doing AI and machine learning when it was probably the least sexy in the public eye, and now all of a sudden people come and says, have you been doing this for 10 years? That's strange. There are lots of connections to the previous talks here. We also have people in the Philippines for doing what I now know is computational labor. But otherwise, we do all our R&D in Gothenburg, but we're a US-based parent company. So we started thinking about this idea back in 2007, that since humanity has become a sensor, everything we write and blog and tweet and put on Facebook and so on is sort of feeding the machines with information about the world in one way or another. We thought there must be something interesting you can do if you harvest that information and apply some kind of analytics to it. So that was sort of one part of our inspiration. The other part of our inspiration was, and I think this is the 5th time we're seeing this picture today, probably. I decided to keep it anyway, because I think one of the interesting things is that even though Deep Blue beat Kasparov, and he won game 2. If you look at this, there's actually a great TED talk by Kasparov when he talks about this, the fact that everyone remembers that he lost game 1, but he won game 2. But the interesting thing really to me is that ever since then, the mid-90s, the best chess player in the world has not really been a human or a machine, and that's actually the theme of his talk. It's been what in chess people like to call centaurs. So a centaur is a fairly good human chess player working in tight interaction with a really good chess playing program. So I really like this analogy because I think this is where the big advances will be, not in terms of AI replacing people, but actually us working together with machines in new ways to be able to do more interesting and complicated things in our lives. So we decided to focus on one thing. We decided to help human analysts who today spend time Googling and searching and trying to understand what's happening in the world. So this can be anyone doing competitive intelligence for a company, someone doing trend analysis, or in our case, doing threat intelligence to understand what kind of threats a company is facing. So we went out and talked to these guys, and asked them, what are your frustrations? So the first one everyone says, which I think we all feel, there is way too much we should be reading all the time. Another sad thing is a lot of this is written in languages we don't understand. It's hard sometimes to find the relevant sources. In this case, for the threat analyst guys, they should be reading dark websites, which is almost impossible to get access to. And then it's the question of prioritizing. Which things should you be spending your valuable time on? So we decided to set up a goal to make the human analyst 10 times more efficient by applying machines in the right places. But the big theme here is really try to sort of organize all that content in a way which is useful for analysis and not just for search like some other companies do. So in essence, what we want to do is to take this tired guy, who spends his entire day sitting there trying to assess different kind of threats and turn it into Tom Cruise of sorts. So essentially, to provide huge amount of data at your fingertips in an intuitive way with the goal of not only looking in the rear mirror, understanding what has happened, but actually being able to say something about the future. And then we apply this to the domain of threat intelligence. So my 1 minute lecture on what people should be doing in security is this. This is how people try to build secure computer systems today. You take all your machines, all your assets, and you put them behind a big wall, and then you try to make that wall as high and as thick as possible. And then the security guys, they spend their time on the inside of this wall, running around trying to check if there's a hole in the wall or if there's someone, some bad guy on the inside. Whereas we think they should spend their time on the outside, checking, does someone out there have keys? Is someone selling keys? Is someone asking for how to get in through the wall? If you go into some Russian hacker forums, you can get fascinating examples of people asking, I hate this company, I'm going to attack it. Can you tell me how to do it? Are there blueprints out there? Have other places like this been attacked and so on? So this is the kind of information we try to get. Just to give you examples of the stuff you can find out there, here's One example, leaked credentials. There are hundreds of sites, paste sites, and various kinds of forums, dark websites, where people are selling credentials, dumps of various kinds. And if you're a big company, you're bound to have some of your accounts here. Probably not leaked from your systems, but actually someone who used their work email at some jogging site or something like that, and then that got hacked, and you're lazy, so you use your same password in some other place. Another example of an early signal is typo squatting. So say, again, this company, Gilead. So a couple of months ago, someone registered the domain gllead.com. Actually, recently, someone registered these kind of typo squatting, similar-looking domains for almost all Swedish banks and financial institutions. So you can sort of, when you see this happening, you know that something bad is probably going to happen to you very soon. So being on the outlook for these kind of things allows you to anticipate, for example, a phishing attack instead of trying to repair things once it's happened. And you can do more sophisticated things. You can do trend analysis. So we apply natural language processing to all the stuff we harvest, and we structure and organize it so that you can actually do trend analysis. You can see that there's a big uptick recently in attacks against banks, meaning that if you are a bank and you don't yet know that you're under attack, you probably just haven't noticed yet. So this is what we try to do. So we built this machine for doing this, essentially to take all these documents. So we're working only with text today, or 99% text, I should say. And then we try to build a system where we can apply, all that data, apply clever algorithms, and then mix it in with the human experts to do something interesting. And we're really using the AI machine learning in 3 different ways. One is to do the organization, to take all this content, analyze it, structure it, turn it into a language-independent representation so that we can do, for example, quantitative analysis over multiple languages, and so on. Then we try to analyze it, so we're looking at, I would not call it AI, I would call it statistics, but to look at various kinds of trends, anomalies, things like that, interesting patterns occurring in the data. And finally, to try to take this data and actually predict things based on what's been happening historically. Can you actually predict something going forward? And I'll come to an example of that as well. I think one thing to note is that, and I think this has been true throughout the day here, a lot of stuff which we today say AI systems are doing is really things where if you human does it, you don't really think that they're very intelligent. Driving a car is not, I think, in the sort of common person's view, something which requires an intelligent, special kind of intelligence. It's things we do essentially without thinking. So I think a lot of the stuff we are doing today is just automating fairly mundane tasks, like in our case, reading tens of millions of documents per day and extracting some information for them, understanding road signs and so on. So I think it's interesting when you think about these things to differentiate between those two kinds of problems, just automating simple tasks versus actually trying to augment humans by trying to do analysis of kinds which our brains aren't really useful for. Like in this case, we have a high-dimensional problem. This is network traffic between thousands of nodes in a network. And the task is to identify which are the infected nodes, something which as a human you just really can't do. But for a machine, the sort of switching up to higher dimensions sort of scales nicely for the algorithms. So what we do then, as I said, we focus on text. So we harvest text. We harvest something like 20, 30 million documents per day. A document for us can be anything from a single tweet up to a big, fat PDF research report. And what we try to do then is, as I said, to aggregate that and make this accessible to humans. Built a pipeline for this. So today we're, as I said, harvesting tons of documents. We do deep semantic analysis currently in 9 different languages, which finds entities and events. An event for us is, for example, a cyber attack event is something where we can say the text is talking about a cyber event, and we try to identify a target, an attacker, and maybe the tools they've been using to perform that attack. And then we do trend analysis. We have, this is old, like a quarter of a billion different entities like IP addresses, threat actors, companies, individuals, and so on, which we are tracking to do this kind of anomaly detection and so on. And then we try to help, and we do this all in real time, so typically a minute from the fact that you tweet something, it's in our system and available for interactive analysis. And then we try to help the analysts in the end over here, both by having a UI where they can sit and play around with the data, and also an API so you can integrate into other systems. Let me skip this. Just sort of a side note here. So, people talk too much, I think, about machine learning. I think all these systems, when you build them, when you build systems for real, I think you need to have a combination of fairly simple cognitive stuff, the kind which machine learning, the blue parts in here are useful for. And then there are other cases where actually logic or rule-based, call it old-fashioned expert systems, are more useful. For two reasons. One is the fact that there are domains here, or tasks here, where we actually know as humans how to express the logic. And I still think that for those cases, those rule-based systems are actually still way beyond what we can do with machine learning in many cases. To a large extent, because many of these problems are really sparse, so you will never get enough data to actually apply machine learning to it. And the other big reason is really explainability, the fact that a rule-based system lends itself easily to giving explanations to why it's recommending something, as opposed to a black box machine learning thing. So as I said, we want to build nice interfaces. Since we've had Ben Schmeidemann mentioned 5 times before, the 3 of us who started Record the Future previously had a company, Spotfire, which was heavily influenced from having worked with Ben in the late 80s, early 90s on visualization. So we have this tradition of his mantra, overview, zoom, filter, details on demand, which we're still living with. So today, what we do in our system is we provide overviews like this. This is from this morning, an overview based on 60 days of historic data. So there's tens of millions of references here to current cyber attacks being talked about. And in this case, fairly simply organized in terms of who are the attackers, what are the different groups there, what targets are they going after. Canada is in a bad spot right now. The tools, methods they're using, which malwares and so on. If it's a hacktivist thing, we track the kinds of operations they're talking about. So op Nazi down is pretty recent, as you can see on the curve here, sort of blooming right now. All the way down to technical indicators like IP addresses, which are seen in bad contexts. We then aggregate information, and we try to create derivative signals. In this case, there's a risk score. So for all the IP addresses we've seen, which is in the hundreds of millions, we assign a risk score. This is rule-based, as I mentioned, the reason being that people do not like us to just present a risk score and say, this is bad, it's 99. So we actually make sure that we have rules here where we can actually explain very step-by-step which different kinds of observations led to assigning this high score. It's an interesting observation. We started out not showing the underlying rules, just showing the score, and people absolutely hated it. For those kinds of things, especially for simple numeric values, which people like, if they can't see the underlying reason why you assign that, it's completely useless. People just don't trust it. Similarly, you can get ideas about, where are you being talked about, and as I said, be able to drill down all the way down to the raw underlying data, the links out to where this comes from. So this is one part, to take all this data, do this analysis, and aggregate it. The other part we wanted to do was to actually make predictions. That's sort of where the name of the company comes from. And what we focus on then again is threats. So we started looking into in which context could we actually provide some interesting predictive information. So we decided, like many others, let's try to find the bad guys, in quotation marks. We were actually a bit inspired by the heavily criticized stuff which IBM has been doing with police departments in the US in terms of trying to predict crime, both actually to predict who will be shooting and who will be shot by doing various kinds of analysis. All kinds of interesting questions ethically here about bias and profiling and so on. So we think in the cyber domain it's less controversial, but it's actually based on the same idea. So the same idea that if you live in a bad neighborhood, chances are that's going to affect who you are. So Kia, for example, who lives in a place where a lot of drug dealers around, is more likely to become a drug dealer than to become a car thief, which Timo might be more inclined to do because that's what they do on his street. So the underlying sort of heuristic here is that the place you live in, where you're located, could actually help us predict if you're going to be bad. But it actually has to be based on up-to-date because things change very quickly. So this is our neighborhood, the map of our neighborhood. It's the IPv4 address space, mapped out in a nice two-dimensional way. And our idea was really that let's use exactly the same model. Let's look at what neighbors you have. If I see an IP address which has never been observed before, which has never been talked about ever on the internet before, can I say anything interesting about it? And the intuition being then that I could maybe do that if I look at the guys living close to me. And I should say that the closeness here is not just the sort of geographical, IP address distance. It can also be other logical closeness measures. like I belong to the same company as the other IP addresses, or I belong to the same network, or I've been registered at the same registration agency, and so forth. So there's actually a set of different kind of proximities which we take into account. But then what we do is that sort of boils down to a fairly simple model. We take historic threat lists. People publish dozens of lists every day of IP addresses which have been observed to behave badly. And then we combine that with the contextual data we get from all the stuff we harvest and the natural language processing we do about that, where we can see if people have been talking about these addresses before they were actually first occurring on a list, and so on. And we use that then to train a fairly sort of standard machine learning-based model to be able to take any new IP and actually assign it a risk score. And as always, if you once you've done this and start looking at the model, you can very often actually understand what it's doing. So it's not completely unexplainable in this case. The essence is really you take an IP address, you look at its neighbors, you can look at the distance, so various kinds of distance metrics. You look at your neighbors, if they are good or bad, and then you can check also, which turns out to be very important, where have people been saying things about them. So maybe if you're mentioned on Twitter, it's not such a great indication, but it still adds up. On the other hand, if your IP is occurring on a paste site, or if it's mentioned on Twitter explicitly at being the source of an attack, that sort of adds to the weight. So this is the intuition about it, and we're actually very happy about this. We can use this model. We can go up to maybe predicting 65% of next week's bad IP addresses, as approximated by coming up on a threat list. I should say, to be clear here, that those 65%, about 50% of that, or 50 units of that, is based on the fact these threat lists are quite repetitive, so about half of them reoccur every day. So predicting this is very much like predicting the weather. We're sort of getting, surprisingly, numbers which are similar to what the weather forecasters are getting. And it's still the same thing, that a strong indicator of whether tomorrow is what the weather is like today. Same thing here, if you're bad today, you're likely to be bad tomorrow. So now I thought I would say something about what we see as interesting challenges, which I hope all of you will go home and spend the next 5 years working on, to our benefit. And I tried to sort of group them into a bunch of different categories. Since there are some linguists on the back row here, I'll start with you. So the big challenge here is, I think, that we're working on really terrible text. First of all, it's like most of the web, filled with bad English. People don't capitalize the names of things. Just that sort of breaks half of all sort of standard off-the-shelf systems today. But also, if you go to a Russian forum, half of the text in one sentence or one post there is going to be in Russian and half in English, and so on. So there's huge issues about the quality of the text. And of course, you have the eternal trade-off of precision and recall here. The next challenge is really in synonyms and disambiguation. I think we've done 4 joint research projects with people at 6 KTH and Chalmers University on doing disambiguation, and I can say this, it's still a great research problem. Surprisingly hard when you look into some of these domains to do that. But I think the most surprising challenge to us here has really been the problem of getting annotator agreement to actually have people classify text so that we can use it for machine learning. And one recent insight I had is that I think, and I'll show you an example here, we'll do some voting, text is much, much harder than images. But I mean, in general, of course, this should be very straightforward. We should be able to write annotation guidelines, collect some data, annotate it, well, maybe decide on features ourselves or do some deep learning and have the machine find the features, train on that, evaluate, and then do this until we're happy. Turns out not to be so easy. And as I mentioned, I think images are easy. I think most of you can find a few cars in this picture, right? And if you look at it, the algorithms are great on this. You segment it and you find it very nicely. You find cars and flat surfaces and so on. So let's do a little exercise here and have you all be mechanical Turks and do some text annotation instead. So I collected a few sentences straight out of our system. And let's see if you think for each of these sentences if they're talking about a cyber attack. Here's my first example. How many people think this is a sentence talking about a cyber attack? Don't be shy. A few. After more, you look at your neighbors and you raise your hand carefully. So good. I would agree on this one. How about this one? No one. Good. So far, we're in a perfect annotator agreement in the room, which is great. This one, then. Of course not. When we first started running these things, we had lots of problems with people using hacked in the other not metaphorical meaning of actually taking an axe or something like that. Here's another one. This is my personal favorite. So nowadays, every single day, people publish thousands of IKEA hacks on the web somewhere, which is great because they figure out that they can use Billy in a different way to grow their vegetables in or something like that. And these things, because again, it's sparse, you get hundreds of thousands of sentences saying hack, which are cyber attacks. The algorithms will learn that hack is a very strong indicator. So to handle these kind of things, we've actually been forced. We first started trying to add more negative examples, didn't work. So this is where we actually, very brute forcefully, that's a good thing, you can be very pragmatic when you're building a product, added top layer logical rules saying that if it's classified as a cyber attack and it contains the word hack and it includes IKEA, then skip it. We felt slightly ashamed, but it works like perfect. Here's another example. How many think this is talking about a cyber attack? This is where it gets more interesting. A few hands. So and it's very interesting. When I show this sentence to customers, maybe half of them say that it's clearly a cyber attack. The rest of them will say, well, this is speculation. I don't want to hear about speculation. I want to have certain news. And the same thing, actually, when I talk to our people internally, they are a bit so-so about whether this should be classified. One thing I forgot to put up here is another great example is that when you get something saying that Justin Bieber's Twitter account was hacked, which again, every day there is some celebrity who has their Twitter account hacked. That's clearly a cyber attack, but when we show it to customers, they look at it and says, that's not interesting, that's a celebrity. I don't care about Justin Bieber. So again, you go back and you tune your system, you add a rule saying that, okay, let's throw in some ontology in the system. So let's classify all the people we know who are celebrities, and then make sure that when it's a cyber attack against celebrity, we downplay that because people don't care about celebrities being hacked. Unless you're that particular celebrity, then we'll solve that on the side. And a final one, this cyber attack or not? Clear, decisive. Good. I would say it clearly is, but again, this is the typical kind of social media stuff you get, where people throw a bunch of hashtags together, and this has very little to do with any human language, really, as such. But still, of course, people classify it. Most of us classify it as such. So overall, not only is it hard to find the data and expensive to annotate it, it's really difficult. And the big problem is, first of all, to get annotator agreement. And second, really then to differentiate it, because people, customers, users of this tend to have different opinions. And as I said, there's tons of risks of overtraining. Our system for some time used to know that if you have North Korea and Sony occurring in the same sentence, it was a cyber attack, irrespective of any other language, just because it saw so many examples of North Korea and cyber attack and Sony being mentioned together. And then, of course, the fact, on top of all these challenges, the fact that languages changes so quickly. New phrases occur. This is ransomware. Before 2012, no one knew that there was a thing called ransomware. And then it started being talked about. Then there was a boom last year because they attacked hospitals in the US. But again, new kinds of expressions emerge all the time. So you can't do your training for this kind of system and then sort of lean back and expect this to perform well, because next week someone is going to talk about these things in a different way. So it's really a very live system. Another aspect of individual user preferences is really the fact that you soon realize that people have very different preferences. We have a guy in Texas who absolutely hates false positives. He's willing to miss a lot of interesting information as long as he doesn't see one single false positive, because it makes him feel bad. And then you have the other guys who are paranoid about missing something. So they instead want to have a system which could give them hundreds of false positives as long as they catch that little golden nugget. And in one way, you could say this should not be so hard to do, but then on the other hand, we are, as I mentioned, we're assigning risk scores continuously to hundreds of millions of entities in our system. And if every single person has his own preference for how we should be doing this, it explodes in complexity. You know, it's technically feasible, theoretically, but economically, there's no point in being in business anymore because it would cost so much for every customer to provide these personalized things. Not to mention that every single user would have to train his own system, essentially, to do it. Of course, all this system generates a lot of uncertainties. You know, so another problem we have is how do we visualize that uncertainty? And not only on the individual level, you know, is this a cyber attack or not, but then you start aggregating these things and you try to provide signal, what's the most important thing to look at? And you get more and more uncertainty. I think it's still a very immature field of visualizing uncertainty in a way that humans can understand it. I'll skip this one. I already talked about this, the fact that people want motivations, they don't really want other things. And then we have it interesting, since people we work with are in the security community, meaning they are all very secretive. And if you ask them, what are you interested in? They say, I know, but I can't tell you. What we've learned is kind of they're interesting in a way, so they're actually willing to be observed and to participate in user studies, as long as it's not in any way telling us what they are really interested in. So it means that we can do sort of traditional user studies to look at how people are using the tool, you know, when do they get confused by the interfaces and so on. But we can definitely, you know, we'll never be able to build a recommendation system based on this because we promise in agreements never to look at what kind of data they're looking for. And it would be even worse if we started, you know, tracking click-throughs and seeing which of our hits are really interesting. Exactly the thing which has allowed Google to be so good in search, you know, by checking click-throughs and building a model on which answers are relevant. We're completely forbidden to do in this system. That's a bit frustrating. You know, we know exactly how we could improve our system, but because of the paranoid customers, we can't really do that. It's a bit annoying. So instead, we do NPS scoring and ask people, are you happy? Would you recommend us to your neighbor? And they say, yes. You know, we're very proud. We have higher NPS scores than some of the most popular companies in the world, which is pretty amazing, given that we can't do a lot of things to improve the service that we know how to do. So, you know, summarizing this, I think, you know, there's tons of interesting challenges, and I think what I think is nice about building a system is this, that, well, first of all, you have to do lots of little bits and pieces, and you have to work together. But also, since you're building a product, you can be pragmatic. You know, the focus. We like to publish what we're doing and about how we do it, but in the end, the most important thing is the performance of the product. So you can do those compromises to do those little things which actually make people believe that sometimes what we're doing is a bit like magic, which is, I think, what any product designer really wants to do. That's it. Thank you.
Thank you, Staffan. And we have time for a couple of quick questions while the next speaker sets up.
Hi, thanks, Staffan. I'm interested in this kind of cat and mouse game, you know, where hackers respond to what you and other companies are doing, and this kind of back and forth. And I'd heard that the kind of area this is happening most of all is in China, with people trying to avoid the censors. And I saw one diagram that was where people had used images rather than text, and they'd skewed it, and they'd put an image over it, and actually what the text said was, I hope you're the best guys at text recognition, because there's actually nothing in here. And so there's this kind of cat and mouse between people who want to put out political you know, messages, and then the government back, you know, trying to find this. So do you get stuck in these kind of cat and mouse games as well?
I mean, that's, you know, that's part of the fun, I think, that you're never done with this in one sense. As I mentioned, I said we did, if you recall, I said we do 90% text. So we actually started doing images, you know, just because, as you say, people are starting, instead of writing out an IP address they want to attack, they take a screenshot of that and they post the picture instead. So we now do OCRing of images on some forums, for example, to detect exactly those things. And you know, similarly, you know, people start. You mean the classical examples is, of course, if you look at terrorism and so on. You know, wedding is a keyword for gathering of bad guys in a room, for example. So there are these kinds of things as well, you know, which manually you can add things to recognize things like that. But I would say overall, I think it's more challenging. And I think it's also, you know, one thing which has fascinated me in working with this is that it's not really us and them in a way. My favorite story on that is we wrote a blog post about how we could notice in our data that every time Barack Obama was talking in bad ways about the Syrian regime, this organization called the Syrian Electronic Army, which everyone thinks is state-sponsored, of course, started attacking American banks. So we wrote a blog post about that, kind of nice. And then what happens next day is we noticed that on the Syrian Electronics Army's Twitter account, because of course they have a Twitter account, they posted, "Hey guys, Recorded Future wrote a blog entry on us on how we work. Isn't that nice?" So in one way, the good and the bad guys are living in the same ecosystem here. And I mean, that's similarly the reason we can find a lot of the really dark stuff is that if you run a drug store or drug shop selling bad substances on the dark web, that's pointless if people can't find you. So therefore, these guys advertise. So what they do is they have their secret little store up here, and then they post a link to it on Twitter, which of course then allows us to find it and go down and check out what they're doing. So I think it's the same network which both the good and the bad guys